Hi guys, I don't know if you can hear it in the background, but it is absolutely hammering it down. Pitch black. It's a horrible day. Anyway, last two sections of the Simplex algorithm, the two-stage method and the big M, and then after this we've only got one more chapter to go. One chapter further maths. We've nearly finished A-level maths. We're going to have like 2 months to revise. It's going to be amazing. So these two techniques are challenging. They're challenging because of the amount of variables you're going to be working with. It's not a really difficult thing to remember how to do, but you've got loads of letters and just horrible things you're going to be calculating with. So let me explain a little bit of why we use the two-stage. So as it sounds, we're going to be doing this in 2 stages. Once we've completed the first stage, the second stage is your standard Simplex algorithm. But the first stage will involve some of these new words here: surplus and artificial variables. And this allows us to solve problems which have constraints like this. We haven't dealt with ones like this before. We've only been doing less than or equal to. So I've copied this straight out of the textbook. And the reason why I've copied all of this straight out is there's not many resources out there. Two-stage and Big M are both fairly new mathematical techniques, and different exam boards do it different ways. So try and avoid using different videos or My Maths or whatever you find, because chances are it will be very slightly different. I'm not going to read through all of that because actually it's better to see an example. But we're going to have a stage 1 where we have artificial and surplus variables. The idea is we need to try and get those artificial variables to 0. Once we do, we then move on to the second stage. So these are actually pretty big problems to solve. This is question 1C from exercise 7D, by the way. So page 204. And I'm trying to maximise this subject to these. Okay, well, these two are lovely. They're less than or equal ones. We're going to need slack variables, not a problem. This one, however, it's a greater than or equal to, so we don't need something to take up the slack. What we need is to add in something that's going to be called a surplus variable. And that will account for any surplus that doesn't come from the X, Y, and Z. Now, there'll be a problem in a second that you'll see, because when we added in the slack variables, you want them to take a whole number to take up the slack. What's going to happen here is we're going to take away a value, and this is what the issue is. So if I go straight into sorting the constraints out, hopefully you'll see what the issue is. Okay, so my first constraint, 5x plus z plus an r is equal to 16. So that's my first constraint. It's got a slack variable. The second one, 3x plus y plus z plus a second slack variable is 12. Okay, so I've got 2 slacks here. Now let's look at the third. X minus y plus 4z. Okay, well, I want that to be equal to 9. And I can't add in a number to take up the slack, so I'm going to have to take away. So I'm going to take away t. And you'll see I've obviously left space, and I'm going to put something in there, aren't I? That's a surplus variable. But when we do the Simplex method, we start off by assuming that x, y and z are naught. And if x, y and z are naught, that means I've got a negative value here. Well, that can't be right. I can't have a negative variable. So what has to happen here is I have to add something back in to try and make sure that that is not negative. So I add in something that's called an artificial variable. And it's artificial because it doesn't really exist. It's just there to allow this algorithm to work, basically. So without us putting this in here, we can't make it work. So it's artificial. We actually need it to be 0. So we need to try and get rid of this and turn it into 0 so that we can then progress from there. Okay? If I had another constraint, then what I'd have to do is maybe use u for the surplus variable, and my next artificial variable would be a 2. Okay, but I've only got 1 here. Now I've still got the same profit equation, objective function, so I'm going to have to deal with this. But, like I've already said, this is going to be a 2-stage thing. We need to try and push those artificial variables to 0. So what we want to do, we are trying to minimize, and we use capital I for this, we're going to try and minimize A1 here. If we had A2, we'd add that in. If we had A3, we'd add that in as well. But I haven't got those. I've only got A1 at this time. Now, using your knowledge of negative, minimizing and maximizing, because I want to minimize I equals A, that's the same as maximizing the negative of it. Okay? So, this is an extra constraint that I'm going to have to try and solve. Well, remember, A doesn't actually exist. And this is where, if people make a mistake, this is where it generally is. Because I need to now replace A1 with a rearrangement of this. So I'm going to rearrange it so A1 is by itself. Okay? So, it's going to be 9 minus x plus y take 4z plus t. So I equals negative 9 plus x take y plus 4z take t. And that is my second objective function. Okay, so let's have a look at what we've done. We've added in slacks here. We've added in a surplus. Surpluses take, and we can't have negative values because the algorithm starts off with x, y and z being naught. So this wouldn't work. We couldn't do the algorithm with it. So we've had to put in this artificial variable just to make the algorithm work. So the first stage of the algorithm is to try and eliminate that. And we do that by minimizing it. So I'm going to maximize it here and replace A1 with rearrangement of this. And I'm now going to plug it all into my Simplex tableau. Okay, let's look at this table. A little bit overwhelming, isn't it? Oh my goodness, it's massive. So, in the basic variable column, we have to put our slack variables. Remember, they always go in there. We don't put our surplus variables in there. We ought to also put our artificials. Because at the moment, remember, the slack are going to take a value, because if x, y and z are going to be naught, then the slack variables have values. T at the moment could have been negative, which we can't have, so the artificial is kind of pulling that up, if you like. So the artificial and the slack variables are going to be the ones that we know for certain have a value. So I'm going to put R, S and A1 in there. If I had an A2, I'd put that in there as well. My objective function and my second objective function. Now what happens when I get to the end of stage 1, this bit's going to disappear, as will that bit. So the second stage, part of this table kind of gets removed. A bit like when a rocket goes up and some of it comes off. I don't know why I said that, it was in my head. Anyway, let's fill in the tableau. So we have 5x, no y's, 1z, 1r, no s, no t, no blah, 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 16. Okay. Then we have 3, 1, 1, 0, 1, 0, 0, 12. Then we have 1x, negative y, 4z, 0, 0, negative 1t, 1 artificial variable, value 9. Objective row for p, minus 3, 1, minus 2, 0, 0, 0, 0, 0. And that weird objective function for I, minus 1, 1, minus 4, 0, 0, 1, 0, negative 9. Sorry I haven't got the equations over the page. I literally couldn't fit it all on. Okay, so this one I've had to rearrange slightly. I've had to put it all onto one side and leave the negative 9, if you know what I'm trying to say there. So I brought over the x, y, z and t to join the I, and it was all equal to minus 9, so I could put it in here. Okay, and then we kind of do the simplex algorithm as normal, but the idea is that we want the value of the I row here to be 0. So we are going to work with this, but initially we're going to be looking at the negative numbers in here to decide what to pivot on. Okay, so if we go through these, again I can't fit 2 tables on one page, so I'm sorry, you might have to keep flicking backwards and forwards. But I look at the most negative, and the most negative here is this column. Okay, I'm now going to work out which rows to pivot on. Okay, I still can't use this to pivot on because it's an objective function. Okay, so let's work out theta. So we've got 16 divided by 1, we've got 12 divided by 1, and we've got 9 divided by 4. So this is going to be our pivot row, that is our pivot element. So what I will do on the next page is I'm going to end up dividing all of this by 4, and then I'm going to do row operations to make all these other entries in this column 0, just like I normally do. But hopefully we'll eventually have most of this go to 0 and this go to 0, and then that means we've got to the end of stage 2. Okay, so next page, I'm just going to pause it whilst I fill in all the basic variables ready. Okay, so we're going to take row 3 and divide it all by 4. Now I know you can't see the numbers from before, you're going to have to trust me with these, okay, because I've got a copy of it up on my other computer. So I'm going to divide all of this by 4. So that should be a negative in there. 1, 0, 0, minus a quarter, 9/4. Okay, and then what I'm going to do, but I'll just fill in the numbers and maybe then you can check. I'm going to do row operations on this column to make these go to naught. So this one I'll basically be taking away this row, that I'll be taking away this row, this one I'll be adding 2 lots of it, this one I'll be adding 4 lots of it. So I'm going to be doing row 1 take row 3, row 2 take row 3, row 4 plus 2 lots of row 3, and row 5 plus 4 lots of row 3. I'm going to pause it whilst I fill it all in. Okay, now wonderfully we've found out from this there's no more negative numbers in this objective row down here, and we've got to the point where I equals 0. Therefore there must be a basic feasible solution, and we can proceed to the second stage. So if at this point you haven't got I equal to 0, then there's no solution. You don't bother doing stage 2. If you get I equals 0, there is a solution. We can now go and find it. Now the wonderful bit here is we can now get rid of all of this column and all of this, because remember these were artificial variables. We made them up in order to do the algorithm. So let's get rid of them. And we have a tableau now that looks like this, a little bit easier because we haven't got that column and we haven't got that row on the end. All we have to do now, this chunk here, so this chunk and then this little chunk here is going to be copied across. So I'm going to do that stage now. Okay, so I've copied that across and you'll see the A column is missing and the I row is missing. We don't need them anymore. So now all we do from here is do the normal simplex algorithm. Okay, so the normal simplex algorithm to try and make all of these non-zero. I'm not going to go through it step by step because there's going to be about 5 tables, I believe. So we'll do the first couple of steps together and then I'll fill in the next couple of tables for you and we can make our judgment at the end. Okay, so let's have a little look. Let's decide what is going to be our pivot, column and row. So the most negative is here. Our theta values, let's have a look. They're not the nicest division sums ever, are they? But at least we're dividing by the same denominator, so that makes it easier. That's meant to be an 11 there. 9/4 divided by a quarter. So the smallest one here is actually this one. So that's going to be my pivot row. That's going to be my pivot element. So I am then going to divide all of this by 19/4 and then do other row operations to make these go to 0. This is going to be one of the most unpleasant steps I've ever done, I think. So this one I'm going to divide all by 19/4, same as timesing by 4/19. That will then go to 1. I'm then going to have to do row 2 take away 11/4 lots of row 1. Row 3 take away a quarter lots of row 1. And row 4 plus 5/2 lots of row 1. Okay guys, those are the steps I just explained and I filled all the tableau in. Again, we can see we've got a negative down here, so we have to keep going. So my next step would be to make this the pivot column. Again, do the values. So this divided by 1/19, this divided by 2/19. This one's not applicable because it's negative. and it would end up as this being the pivot row, this being the pivot element. So my next tableau, I'm going to divide all of this by 2 over 19, or times it by 19 over 2. These I want to go to naught, so I'll be doing row 1 take away 1 over 19 lots of row 2, row 3 plus 519 lots of row 2, and row 3 plus 7 over 19 lots of row 2. So that will be my next tableau, and my S will get replaced with T. Okay guys, so that's what it looks like at the end of all of those steps. The numbers are slightly nicer now, but please don't panic if you're doing a question like this in the exam and you get horrible numbers out like this. It kind of makes you feel you've done it wrong. I remember at university I took a course and it was called Combinatorial Optimization, and we had to do some of this simplex algorithm techniques, and I had trigonometric functions in this and I was manipulating with it. It was horrendous. I did get it wrong at the end. I made a silly little mistake and I did get part of it wrong. So, not surprised though. Okay, so yet again, I've got another negative in here. Will this ever end? In the exam, they normally only get to do 1 or 2 iterations. They wouldn't get you to do anything this big. They want to see that you can do one step of it, not the whole thing. So we've got a pivot column. Again, I'm working out value divided by this. These two are both negative, so I can't use those anyway. So the only option I've got is here. So it seems like I need to bring R in instead of X. So I'm going to take all of that row and times it by 2. I'm going to have to add on 11 over 2 lots of row 1 to make that go to naught. Add on 3 over 2 lots of row 1 to make that go to naught, and do the same for that one. Okay guys, last tableau now, thankfully, because these are all positive numbers. So our solution after all of this is that we can get a profit of 24. X needs to be naught. Y needs to be naught. And my R is going to be 4. My T is 39. And Z is going to be 12. So whatever I'm making of these, I don't need to make any of X and Y or sell them or whatever I'm doing in this situation. X and Y both naught. Z needs to be 12. And that gives you a profit of 24. Okay? So I want you to have a go at some of these. I know they're not easy. You'll want to look through the steps as you have a go at these and follow it step by step. There's one question which is talking about minimizing. I think it's 1B actually, is a minimizing problem. When you do that, the only changes you have to make is, you've looked at it before, you need to maximize the negative of the objective function. And then when you get right to the end, when you've got your profit, let's say it comes out to be 5, then your profit will be -5. Nothing else changes. Okay, remember you might have to have more than one artificial variable. I don't think there's any more to say. Do your absolute best. It is quite challenging. If you've got any questions, let me know. Okay, best of luck. Bye.